Welcome to the English translation of Why the Card10 is Not a Medical Product by Phil, live from the 36th Chaos Communication Congress in Leipzig. Your translators for this talk are Ludwig and
Duckman.
Thanks for allowing me to present something here, to give a talk here. I want to say something about my person. I was announced as Phil, that's right. I've worked for over 10 years in the medical production, and I can understand if it is not very interesting for everyone, but I like it. I will bring a lot of examples. That means laws are very precise, and this will be a bit diluted with examples. Some things are extremely simplified because I don't have enough time. Don't take everything word by word, but just as a first approximation. More is not possible here due to the time. So first question is around who knows what cardio is? Who has one? Okay, good. Then I'll briefly explain something about the hardware. The cardio, I stole a picture from the homepage. It is the standard organizations would say wearable, so you can wear it at your wrist. You can use it in the at home, and mostly it has a lot of diodes, blinks, has rotation motor. So at the first glance, it's not a medical product. What you can see at the picture is like large metal pieces where you can measure ECGs, where it's the first point where it kind of looks like a medical product. So that's the first step where everyone has to go through. Medical product is a medical device, is regulated via the European regulation and the medical device regulation, which is valid in all of the European Union. I want you to read that article 2 of the medical device is what you can see here. So it's a medical device is a device or a software that, according to the producer, has one or several of the following medical purposes. The important purposes are for the ECG is that it has a purpose of diagnosis or surveillance or something similar. So it could be that similar sensors are in a different product, where the producer says that the manufacturer says that it is not a medical device, for example, in smartphones, and then the manufacturer has to look for what has to be done, and so that answers the question how it is with the cardio. Here, great. So the purpose of the manufacturer regulates exactly this. So the purpose has to be in the manual. Maybe you can find it on the web page. You can have an ECG here. Nice. That's something which looks like it. And then there's like a long text which describes how you can do something with the data from the ECG. I did this, looked like this, and what's the purpose? I didn't find anything which was supposed to be for indication, nothing for measurements of ECGs. I don't know which diseases are supposed to be diagnosed or surveilled. I don't know anything about users or patients, so it doesn't have a purpose, official purpose, so it's not a medical device. That's my judgment. So let's look further. We could play the game and make part of the cardio to a medical device. Easiest thing would be to make the program, which shows the ECG, to a medical device. Medical device need a purpose, and this could be the start of the purpose. So the ECG app, so piece of software, is made into a medical device by describing how it works, what you can do with it, what is a medical reason for using it. In this case, if there is a regular sinusrhythm, or if there is an atrial fibrillation present. This should be possible with a cardio. I have 2 electrodes, so medically speaking, I have a cross section through the heart, so I can illustrate. Larger ECG has several electrodes which correspond to different cross sections. This is not possible with a cardio. Second point is, where is it supposed to be applied? So describing the environment. Next point is who is supposed to use it and who is not supposed to use it. That's what this has to be answered by medical professionals, and this is how you could write an official purpose for the ECG app. So to summarize, function and indication, the patient group, and the contraindication. This is an official purpose, all the parts you need. So we have a purpose, so what next? So according to the purpose, we can classify the product according to law. The classification rules are in the law. I always try to write down which article or annex has the rules. I'll show you now. The classifications are as follows. From a technical point of view, it's not invasive, so it's not this. It's not an invasive product. There aren't special rules, but it does have. It is an active product, and so Rule 10 applies in this case, which is called diagnosis and surveillance. I want to show as an exemplary, as an example, the Rule 10. So products of Rule 10 are products of Class 2. So then there are additional things which are applicable but not very interesting for the cardio, and the red part here is an important part. Control of vital body functions. And if you are part of this category, then you're Class 2B, which would apply to the cardio. So that's my opinion. Now we have a purpose, now we have a classification, and how to proceed. The classification determine how you can bring it to the market, into the market. The higher the classification, the more you have to do. For example, products of Class 1, there's no risk, you don't have to do much, like Band-Aid is Class 1. Every thermometer is a Class 1 product. Class 2A is more interesting, where's a risk in applications. For example, dental implants, devices helping you hear, Class 2B, a bit more can happen, where the products are also more invasive, for example, dialysis devices, endoscopes, condoms, perception. And then class 3, that's a real thing that's like implemented hard.
That's heart catheters, pacemakers, AEDs, with a significant risk that far exceeds class 2B. So we've classified these, and what do we have to do with this? And I'm going to shine a light on what's supposed to happen here from left to right. So for every product, you have to have a quality management system. Products of class 1 can do it in an easier way, but basically every single product has to have this. Another thing every product has to have is technical documentation, in which you record what happened during development, every little thing. Next step is, it's not cooperating, the audit by a designated person. You don't have to do that for class 1, but you have to do that for all other classes. That designated person does not assume any risk, but this ensures that a neutral party is involved. For class 3 products, there is a special product testing. They're of course the ones with the highest risk. Then there's the CE certificate. And they basically tell you, yes, your product is conforms to the CE regulations, so you're allowed to put the logo on it. In the next step, a unique device identifier needs to be attached to the product. It has to be registered and has to be both on the product and on the packaging. And the last step, that's not cooperating again. Last step is upkeep of this whole quality management system and all the processes. Okay, let's have a look at this. As an example, what you have to do for class 2 product. So, a quality management system is required by law, and industry has determined that the letter of the law is a bit difficult and can be interpreted. So that's not always that easy. So audits are expensive, so what happened? Norms, standards. Standards have many good sides. There's less room for interpretation. They're a lot clearer than a law. They are internationally recognized. So if I go into one country, I can use the same norm piece of paper in the next country. And that's overall makes for an easier audit, which means cheaper. Hence, almost everyone uses the standard. Then there's the expectation of standards. It's in the Vienna Agreement. And if I conform to certain parts of certain war norms, I also conform to certain parts of some laws. So it doesn't have to be checked for conformity with law. That's just automatic. I actually don't remember this slide that much. So a quick explanation. What categories of standards are there? There's 3 main categories. There's general. That's often process standards. Then there are standards for electronic technology and telecommunications. Electronics technology means everything with a plug. Telecommunications means everything that has a radio. In Germany, there's 3 organizations that do this. That's the DIN for general stuff. DIN A4 is a standard paper size. And then there's DKE, VDE, and DIN for the other 2 categories. In Europe, we have CER, who do the general norms, and electrical stuff, and then we have Etsy for all the radio and telecom standards. Internationally, we have the ISO, which does most of the process norms, the IEC, which does the technical stuff, and the ITU, which works on worldwide telecom standards. And let's take a look back to where we stopped. We stopped at the QM system. Here's our first achievement. We have the ISO 13485 QM systems. So this is the first standard that is relevant for our medical product. Roughly, it looks like this. It's highly impressive. It's very large, actually. And the significant part of this is business standards. You have your quality policy. You have to have a quality management handbook. There has to be an overview of the company, of the process in the company. What processes do you have? It's a top-down look. In the standard, it says that the highest executive of the company has to have this as their job. This is, the employees are not allowed to do this. It has to be the leadership of the company itself. And this is subdivided into smaller aspects. And it goes down to various other documents. It can basically be everything. It's a hierarchical top-down system. In the QM systems, a lot of things are very well defined. So please look impressed. This is the sort of thing you find in a QM system. They basically want a process for every possible eventuality. If you want to do this yourself, don't be too impressed. The hot topic is risk-based. We looked at the most important things, did our assessments, and now we're starting what's very critical. The designated persons know this. They have their guidances for it that they have to obey for the audits. You can get better bit by bit. Then there's development. The next standard is ISO 14971. It's a standard for risk management. So I'll have to have a quick look, or rather explain what kind of steps there are that you have to perform. The first step is, what did I write down? The edge cases. You have to determine what are the functions of the device, what risks are derived from these functions, though the standard says threats. Threats are defined as a potential source of damage. And these threats
you have to, from events that can happen, you can go to a risk situation. So a lamp at the ceiling can fall down, but as long it's a hazard, but as long as no one's underneath it, it's not a hazardous situation. Only if people are close to it, there's a hazardous situation. From this situation, you have to go to risk. Risk is defined to be the combination of probability of a hazardous situation happening and the resulting damage. These two values you can write down in a matrix and determine parts which where you say it's like completely unacceptable, and other parts where you say it's not acceptable, but we'll leave it for now because the use of the product, the advantages of the product are more important, and that's what's written down here. Next step is the risk evaluation. where you say, I've identified my risks, I moved from hazard to risk, I have my graph. How many risks do I have that are acceptable or unacceptable? This whole process is a risk evaluation. Next step is risk control, where you want to have functions which reduce the risks. First one is function modifying the design, where you change the product in such a way that it is not technically possible to that the risk to occur for the risk to occur for the ECG. That's not really possible. Is a product something that creates a lot of heat? You can maybe change it where you take induction instead of gas to reduce the risk of someone burning their finger. If that doesn't work, you have to implement protections where you can move the probability, but the risk still is there. The third possibility is to inform people or school people, and at the end of risk control, and more is not possible. Next step is risk acceptance. You sum up all the risk and look at, after minimizing the risk, is it acceptable? If this is also the case, you write it down in the risk report, and in the last step, the last step, did what you write down work out, or did you totally estimate something wrong, or are there new risks? And this is also part of the process. Next standard that is applicable is IE 82304 about health software. So let's look into this. The standards are from a time where no one could imagine that software is an independent medical device. Basically, all standards were written by people who were very much focused on hardware and mechanics, so you'll see a lot of V models or waterfall models, and that's also how this norm starts. This is a lit because you forgot to classify software as a medical device. So now you say you've done everything for software, nice, but don't ignore the whole environment where the software will live. So you have the system requirements. Then next step is the life cycle, determined in the IEC 62304. Then you have to verify the system requirement, and on top of that you have the validation. And these are two terms which have to be differentiated. Verification is objective tests that certain steps are objectively verifiable. So, for example, you can put a ruler next to it and you say, yeah, that's inside the error tolerance. Validation is defined that specified users, specified product in the specified environment can use, people can use this product. So you can verify the product, but people can't work with it because it's, for example, if it's too dark and people can't see anything, that's here the standard at the validation on top of the verification. Additionally, you have some byproducts, like some files, which have to be created, which comes in via the hardware products, like the manual for the hardware or other stuff. And there's also a last step where you have to keep up with.
And we have the next standard that we mentioned already is IEC 62304. That's a pure software norm as a standard. It was developed in a time when people thought that software is always part of a medical software product. But then there were medical products whose software was so bad that their own standard had to be invented. A good example is the Therac 25, a radiotherapy machine, which didn't quite work and literally burned the patients on the table. So much radiation was dumped into the body that the people ran away screaming, and that's how this standard happened. And standard starts at the beginning and says, so you want to develop software? Okay, but you have to plan it. You can't just start developing, but you have to think about what you want to do. This starts with software standards, goes, you have an architecture, implementation, verification. The standard says plan all this in the beginning. Plan how the integration is supposed to happen, and don't just start coding. The next thing is the expectations at the software. How do they have to look? What do you have to... And there's software architecture. And the standard says it identifies software systems. So everything that has its own processor, its own CPU, DSP, FPGA, is a software system. You have to identify those. Break your software architecture down into a detailed design. Here, software items and software units are mentioned. So a software system breaks down into software items, and software items break down into software units. And that's the end of it. The exact change in the definition between software item and unit is that with a software item, the person making it says, I can't take this apart any further. If you go all the way down, you end up an assembler. You can do that. But most manufacturers say, yeah, this library, it's made of a lot of stuff, and you can't really take it apart. So they have the freedom to basically do what they think is right at this level. The whole thing has to be implemented, and the standard says you have to obey these things. First, you have to verify your design. Then you have to integrate your architecture, just like you planned in the beginning. Then you have to verify the expectations, and then the software is released. Here too we have certain things that are general, that have to be done at every level. Then there's software repair or patching. So it says you have something on the market, but what do you do when something doesn't work like it's supposed to? There's software configuration, which means what deliverables or what tools are you using? Is there a versioning system? Is Git happening? Is there a branching workflow? All this is defined here. Do you have an integration server? If yes, what do you do with it? How do you update it? How do you manage that? All this has to be done, and these processes are exactly for that. Then there's the process for solving problems in your software. So what has to happen to changes? What steps do those changes have to go through? So let's have a look. Should actually, yes, nice. And there's the next standard, IEC 62366. That's the one about, as they say in German, Gebrauchstauglichkeit. In English, it's usability. Usability subdivides into in multiple parts. The core thing is you can't sprinkle usability on top at the end, but you have to keep the concept in mind from the beginning. So there's a development process for this that starts in the beginning, and at the end you have to evaluate it. The standard talks about formative and summative. Formative is what happens during development, and summative is what happens at the end. Then, here too, you have to look at the purpose. So, define the users, define the environment. What can be done with this thing? How does this thing work? So, every single norm involves these factors in some way. They at least have to be described. Then usability has to be specified. In the simplest possible case, this is more or less a style guide that says our product is constructed like this. This is how you operate it. We use this and that design, this arrangement, these design patterns. And these have to then again be verified. So, best case, I can use automated checks. Do these elements exist where they're supposed to be, where we defined they would be at the beginning? Or do the menus change like the design guide says they're supposed to? Just like everything has to be verified, it has to be validated. So I have to get real users and check if they can actually work with this stuff, ideally during development. So then we have ISO 15223. This is about symbols and such. This is one of the cheapest. This is not an error, just $1,000. The standard itself is a lot cheaper again, but you just have to know where the symbols are supposed to go. The nice thing about this one is that it is only for medical tech, but the ISO is so nice that the symbols in general can be viewed at their homepage. So you go to the ISO page, don't look for medtech, but look for ISO 7000. And then you can move through the ISO homepage, and at the end you're gonna land at for the preview symbols, which can be used here. And you can click on them, you'll get them in big, you get them digital, and you can just put them in the documents where they need to go. That's actually kind of neat. At the end, I'd like to say that the purpose, or the definition of purpose, is the important bit of text. A lot of stuff is determined here. If you don't start with this keystone properly at the beginning, you're going to have immense problems as soon as external audits happen. So in my case, I said, yeah, cardio, yeah, nice, awesome. But it's just the software on the device. If it was the whole thing, then the whole hardware would be a medical product, and we'd be in a whole other area. We'd have to have the 6061 standard and a lot of other regulations. So REACH, ROSE, EMV, that's electromagnetic compatibility, biocompatibility, radio norms, shake tests. So yeah, if you can avoid this, that's a good thing, and it's a good thing for the maker of the product too.
Exactly how it is represented in development models, because a lot of manufacturers are hardware manufacturers. They only know this V model, which is one of the most established models in the medical manufacture from medical manufacturers. There are a lot of companies who do this. What turned out to be is that you still require usability, but as soon as you have those, you say we have our Scrum project process. We are in a regulated market. We can say that at the end of every sprint there have to be concrete documents, and during the process I can take documents from the folder and can design your verification and go up step by step, and in an agile process I can go through mini Vs, and that's what's happening usually in the industry, and a lot of different things. I also haven't seen a lot of different things there. That's what I said just now. V model is very important. People don't know anything different. What doesn't exist yet are standards for security and safety. There are guidances. The BSI is part of the standard of the committees of creating the standards. It's a funny thing. If I'm part of this, I'm called young because I reduce the average, the age average by 25 years. So they just don't think about topics like this. There will probably be 2 or 3 new standards next year, but at the moment there's nothing, and the manufacturers don't really care about it that much at the moment. The manufacturers and the users fight a lot. Manufacturers say, "Oh yeah, you have this great device. This can do a lot of fancy things in the networks," and say to the user, the user has to take care of all the security because the manufacturer said that's not my department. We'll not take care of that. We'll see how that turns out. Now we are done with the development. So now is the noted body comes in and does the audit. First, they want to see the documentation. Depending how much they want to see depends on the classification. Next thing is the audit of the 13485. Where if you pass, you get a certificate, and then there's another certificate, which by law allows you to put certain things on the market. You then declare the conformity. That's very important in the EU. There is no there's no admission by the state. In the US, you go to the FDA and they admit your product, approve your product. In Europe, you do this yourself. This is written in the MDR Annex 4. In Annex 1, it says, in Annex 4, it says, do all the stuff written in Annex 1, which is like basic security demands. In Annex 2 is technical documentation, and in third step is surveillance of the process of putting on the market. A lot of manufacturers already have this, but now it's also written in law. Then we can explain the conformity with a conformity explication, which has to be a formal document with specific things in them. What's the company? Where do you find it? You have to have unique numbers. You have to name the product uniquely. You have to have the risk class, the noted body. For products from the class 2A, 2B, and 3. And last thing is a date, and this has to be signed. So that's one of the few documents where you really have a formal, heavy process. If this is done, that's great. Then Annex 5, you get the CE certificate, which is exactly what it means, that you have declared the conformity, that it is safe according to the noted body and the manufacturer, and underneath you have the number of the noted body. In this case, 0, 1, 2, 3. Depending on where you go, you might have a different number there. So next step, you have to register the UDI, the unique device identifier. This has to be not only on the product, but also on the fabric. To talk about this, would cost too much time, but I want to talk about this very briefly. There are two parts, the UDI-DI and the UDI-PI. The DI is static, the static part which identifies the device, the company. This is a part that is more or less static, and then there's a second part which is dynamic. When was it produced, the lot number, until when is it usable. So this number depends on how much you want to put on the market or how much you want to produce. If you registered the UDI, you manage to complete the development process and can go to the last step. The next step is chapter 7, surveillance and vigilance and these sort of topics.
Upkeep means you have to renew the certificates. They all come with a best buy date, and I believe even the Declaration of Conformity has one. And well, let's have a look. Yeah, it worked. So you have to have continual audits. So these audits may be surprise audits. You can, as a maker of the device, you can audit the people you buy the parts from, and you can be audited yourself. There's a video from a French company that is both in the role of a device manufacturer and a component manufacturer. They had about 20 audits in a year, and well, a noted body had a look at us. The makers who we develop parts for came, and well, basically just use the same piece of paper over and over. These audits are a highly formal process, and well, usually you have a so-called front room, back room setting, which means that there is one room where you go with the auditor, and the auditor never leaves this room. If the auditor wants to see something, he asks what's the purpose of this thing, and then just sort of digs through the paperwork. Backroom listens via Skype or any other form of audio, and will, on demand, if it's a paper-based system, literally stand next to the printer, make copies that are marked as such, and bring them to the front room and say, here, my dear auditor, you wanted this, let's see if you like it. In digital systems, this is a lot simpler, but this is a typical setting. That you sort of disconnect these areas. Okay. So these processes belong to the quality management system. So you need one for market surveillance, for product changes, and for continuous improvement, or for CAPAs, corrective and preventive actions. And yeah, with that, I'm actually done. That was one whole product development and upkeep in very rough steps. I got a podcast if there are any questions. Thank you.
Phil, vielen Dank. Dann haben wir jetzt sogar noch Zeit für Fragen. Wir haben Saalmikrofone hier auf.
So we have time for questions. We have 3 microphones, number 1, 2, and 3. Please just go to one of them if you have questions, and I'll point at you. We haven't got anything from the internet yet. Something may be coming, but microphone 2. Hello. With many slides, you can replace the heading medical technology with automotive or aerospace technology. It's basically the same. The only way the standards are different is by the number, but it's basically the same topics: quality management, risk management, and so on. Is there something in medtech that deviates significantly from critical systems in other areas?
From the requirements, not really. Every regulated part has certain things that have to be regulated. What's special about medical devices is, like, a plane is always kind of similarly constructed to for medical devices. For other products, this has to work from Band-Aid up to devices implemented in your heart, and representing this complexity is very difficult because no producer really finds himself represented, and that's a difficult part for medical devices, but the requirements are the same for all regulated areas.
Okay, just a short comment. The whole thing about software that's sort of tacked on at the end as an afterthought, and how the standards were written based on hardware, it's that way in every area.
I know this from aerospace technology, where you rather change 5 hardware devices before you touch the software. It's not that bad in for medical devices.
Okay, mic 1, please. Hey, thank you. This all sounds quite complicated, and for me the question emerges that what is the standard? What actually forces me to treat my device as a medical product? Where's the law? Where's the initiative that makes me not say, yeah, I'll just forget the certification, it's too complicated?
The pragmatic answer to this question is, if there are companies which compete with you, they will sue you, and what happens then is that it will come in front of court, and then someone appointed by the judge will do the job. And if it is obvious, if it's obvious for some devices, you can if you're supposed to be applied to a heart for a patient which is alive, you can't really argue about it. You really should think about if that you really aren't part of this classification, otherwise you get the purpose report. You really have to read the report. But I mentioned earlier, was also the differential what's written, what's different from pharmacology. And
okay, mic 2. I have a smartwatch here that has an ECG, but in Europe it's deactivated, like from many other manufacturers. We've just seen a well-defined process for doing this. So why don't big companies like Samsung or Apple, why aren't they able to do this sort of thing?
The Apple Watch is a great example. It is at the moment in Europe a medical device. Not even the Apple Watch, but they did the same trick. They declared 2 apps as medical device. One is the ECG app, which has more or less the same purpose as we saw here, and the other thing is the app. I think it was detection if you fall. And those 2 things are medical devices and not more. And for these 2 things, you can find a purpose declaration and you can find the CE symbol. And if you look at this, you see exactly what we saw here with number 0123, where the TÜV Süd was part of the conformity process, meaning that it is at least class 2A product. And with the whole hardware, Apple said to itself, it does make sense. The hardware. So the main goal of the Apple Watch is not medical device. Everyone's supposed to develop for the Apple Watch. They can't and don't want to control it. And so they said, For these two parts, we keep our independence, and only for these two things we have medical device status.
Okay, I was interested in why the hell this takes so long. The Apple Watch took months to get certified.
That's right. In this case, Apple is a US company. They made the first application at the FDA. They knew exactly what they had to do, and the FDA is a government organization with strict processes, and it is easier to predict when they get the clearance from the FDA. You have in Europe, you don't have this clear process. You only have the guidelines along which you can orient yourself. The TÜV Süd can say, oh, well, it's nice what the FDA said, but we have another standard here we find applicable. So you have to give us documents that you fulfilled this, and then Apple has to deliver. And the FDA is not that much standard driven, it's law driven. And that's why I think it took longer for Apple, because they looked at the problem from a different mindset, because they are American.
Super, dann schalten wir mal rüber ins Internet.
Okay, let's switch over to the internet. Yeah, short question from the internet. How much do those independent audits by named party cost?
It's like this. The producer looks for a noted body, like DECRA, for example. In Europe, a noted body from Europe, and they pay money to this noted body, and this noted body performs the audits. That's like kind of an interest of conflict, but the noted bodies are very loudly saying that we get the money from the company, but we can prove on paper that we followed the procedures and didn't just let any shit get through. And there was some critique of some noted body, but they were able to show that they did everything they possibly could, but that they can't protect itself against crimes.
Okay, Mike 1. In developing medical products, a lot of documentation is generated. Is there any way for the patient or for the user of the document, of the medical products, to get their hands on this technical documentation?
No, it's not possible. We are at the moment laws are changing. At the moment, we have an old law, the MDD, which is still valid until May next year, and afterwards the MDR is valid, and afterwards there is a European database which is not completely public, but partially at least. But the companies say that's our business secret. That's the core of our company. We can't just make this public. The law says that certain things has to be in the manual, that certain things have to be noted, the UDA or the certificates, that's this has to be on the product, but not the documentation. You could try to write a Freedom of Information Act at the FDA to get the documents, but the FDA will say if you do this once, no one will ever come back to us. So no, it's not possible to get the documents, but only the documents for the users.
Okay, Mike 2. Yeah, thanks for the talk. And I've seen it very often that very small companies do algorithms to CT or MRI images, generate new images from that, analyze them, and say, oh, we're not a medical product, we're just doing this for scientific purposes. And then if you, dear doctor, use this data clinically, then you're doing it for yourself because you're making the decision with the data you received from us. Is that legitimate in any way, shape, or form? Is this doable for small open source projects that want to do things with images?
That's a gray area. If the manufacturer says this is only for clinical research, this is only to test something, and then you use it for something else, the manufacturer will say the user is responsible. If it's happening in a larger context, then a noted body or a government organization will step in and stop it, and then it will go in front of court, and then someone appointed by the court will write documentation. Another thing is that there is also software, for example, in radiology, where this doesn't happen anymore. If a manufacturer just goes there and says we have a radiating device and then takes a software from a small company and then looks where it has to shoot through the body, that's not going to happen. With other cases, possible, but it's the question if that's happening.
Dann gehen wir rüber auf die 1.
So let's go over to number 1. Yeah, my question follows this one. How is standard adherence actually enforced? So if doctors use the cardio on patients to surveil something, or flower power enterprise, some products, whatever, use that stuff because it's cheaper, who would realize this, when, how, and where, and what would be done about it? I mean, you can't do anything about it if someone uses the Card10 like a medical product. What can be done about this, and who would get hit?
The easiest way is to go via the BfArM, that's government organization in Germany responsible for medical products, where you can complain and they'll take care of it. Of course, from time to time they have a lot of to do, but that's the first organization you have to contract.
So who would actually get punished? A doctor uses Card10 as a medical product without it actually being one. Will someone decide that Card10 actually is a medical device and Card10 would have a problem, or would the doc have a problem?
That's what the assessor has to determine. That's what comes out in front of court. If it's not a medical product and can't detect and diagnose any illnesses, which is, according to my opinion, true at the moment, then the manufacturer will be liable because they use something, the product, which is not, doesn't have the purpose. The device says you exactly when happens what. In this case, the manufacturer is also reliable, but this doesn't happen for the cardio. This all depends on the purpose of the device, so you have to kind of guess what will be written in the report by the assessor.
Got anything from the internet? Well, okay, then we'll do mic 1, please. Hello, if I understood you correctly, then Apple said that the Apple Watch is primarily not a medical device. It has other purposes than measuring vital parameters. I don't know the product Card10 personally, but does the hardware have any other purpose except medical-ish things? Oh, okay. So, how did you get out of that bind? Because just from this talk, it sounds like the thing is primarily for medical purposes.
Okay, I highlighted the medical part because that's where I'm expert in. The cardio on itself can, apart from 1,000 other things, also create an ECG, but can only visualize it not very well. Schneider, I'm sorry. The thing can or should be used for much more than the ECG, where I'd say that people are supposed to write software, it should be accessible, should somehow connect with other cardios. You should write, create fancy things for the display. You should write the settings if you want to talk with other people or not. It has to blink, and that's where I start, where I'd say the ECG is also part of it, but it's also just a toy. It's not what the cardio is supposed to be.
Well, I believed from the talk that it was only usable for this one thing, but yeah, that's a good answer. Thank you. And we're going to continue with mic 1. Good evening. I have two smaller questions. First one is, could it happen that something like Google Scholar or PubMed that docs use every day to make decisions about their patients, could it be that that is a medical product by law? And secondly, the difference between Cat 2B and Category 3 is a life-threatening or very dangerous decision. In software, at least it looks like that to me. In medicine, it looks like patients can easily develop allergies to everyday medications, penicillin, for example, and could die from those. So, how is it dealt with that even banalities can have devastating effects in medicine, and how that a small, tiny product should essentially be built to the same standards as a robot who operates on my heart?
Second question I can answer rather easily. This has to do with the classification rules. I only presented the rule 10. For this product, for each product you have, you need to know the function, the purpose, and then you can go through the rules, and there it is explained exactly if you have a product which has specific features, if it has a specific invisivity, then you land on specific categories. To show other rules here would be very hard, so it's kind of difficult. For the first question, we have to meet in private.
Yeah, well, I was talking about Google or PubMed or UpToDate.
I don't really know what they do, so I can't say much about it. I'm sorry.
Okay, we're out of time and no more problems, so thank you very much. Thank you for
listening to the